Welcome back to the Algebra 2 series, and this is our third video in a series about the hyperbola. Today we have two examples, both of which can be very confusing. They give certain amounts of information, like this one has the equation of both asymptotes. As you see here, you got the plus or minus in there, which indicates that both asymptotes were given, and they include one vertex, and they'd like to know, in this case, what the equation is in standard form. Well, obviously, it's good to sketch things out a little bit, but one of the items that we see right away is because in line form, y minus k is equal to plus or minus the slope, m, and then in this case, x minus h. And notice in this case, we do have that negative 3, 0 is our center, or of course, that's hk. Knowing that that's HK helps us out a lot because that gives us a place to start. So if we go to negative 3, 0, negative 3, 0, that would be on the x-axis, not the y-axis. Let's try that again here. Negative 3, 0. There we go. And notice that the vertex that was given was negative 3 and 4 up here. Negative 3, 4. So this distance from the center up to the vertex does two things for us. It tells us that this is a vertical hyperbola, and it tells us that a is equal to 4. Those two parts are fairly critical in solving this problem. We're trying to write the equation in standard form, and since it's vertical, we know that the y minus k has to come first, and that's going to be over a squared, minus the x minus h squared over b squared, and that's all equal to 1. So in this problem, we've been given several items. It looks like we really only need to solve for the b value. Let's plug the things in that we know. We know that this is going to be y minus 0, or just y squared. We know the a is 4, so that's a 16, minus, in this case, x plus 3 squared over the b squared. I'll leave that blank for just a minute, and we'll fill that in at the end. And of course, here we see all of this information that the A represents. The A represents 4, but it also represents the rise in the slope, the rise over run. And so we know here, since it tells us that the slope is rise over run, that's 1 over 2. The rise must be 4 over 8. And so that's going to tell us that we must move to the right and to the left 8 units in order to get a slope of a half. And that's the slope of a half for our asymptotes. So that's critical because that will tell us what the b value is. So this right here is going to be 8 squared, or 64. I did that kind of fast, but again, we see what this tells us. In the case of a vertical hyperbola, that is going to be rise over run, in this case a over b. And that's why we equate that 1/2. It's not 1 and 2, it's instead 4 and 8. So I'm just going to box this and run. It looks like I've got my nice equation there in terms of writing it in standard form. Let's move on to the second example. If the first one wasn't difficult enough, we've got this one. A horizontal hyperbola has only one asymptote given. Now that right there is clue enough that this is a dangerous problem. It has a focus at the point 8,2. The second thing that makes this really tricky is that instead of giving us a vertex, they give us the focus, and they want us to locate the vertices. So this is a crazy problem. Let's try to graph it and see what happens. In this case, I'm going to graph the 2x minus 4. So 2x minus 4 is going to look something like this. It's going to go through these two intercept points, so I'll just draw that up. That is one asymptote. And 8, 2 here, now this is kind of interesting because if I go with a slope of 2, I'm going to be right here at the point. I think I've located a point 3, comma 2, and this is the point 8, comma 2. And that gives me some good information. So let's see what that tells us. That's going to tell us that going directly across here from, this is a horizontal hyperbola. If it's going to be horizontal and my focus is here, and that must be the center. So I've got C equals 5. Now, of course, I don't know where the rest of this is, and I'm trying to locate the vertices. But I do know this. The slope of my line, the slope of this line, m equals 2, and that equals rise over run. Now, in the case of a horizontal hyperbola, that would mean that that would have to be the rise is b and the run is a, because a is going to the vertices. So I know then that 2 over 1 equals b over a, or in other words, b is equal to twice a. That's important. And the reason that's important is because now things are starting to come together, and I see that my C value, which is over here, fits into my Pythagorean identity for the hyperbola a squared plus, a squared plus b squared. Sorry, I'm getting excited because I'm getting so close to the solution here. A squared plus b squared equals c squared. I don't know what a and b are, but I do know their relationship right down here. So I am going to replace b with 2a, and I'm going to replace c with 5. That's going to be 5 squared is equal to a squared plus 2a squared. Now I've got to put that in a quantity so that I don't forget to square the 2 as well as the a. This is a squared plus 4a squared equals 5 squared, or 5a squared equals 25. Now be careful here. That means that a squared is 5. How about that? What that also means is that a is radical 5, and we can answer the question of locating the vertices because we see from the center 3, 2, we simply have to move to the right and left radical 5 units. So I'll finish this problem by simply writing, let me mark this up here, that the vertices are located at 3 plus or minus radical 5, comma 2. And that gives us what we need. Now, of course, we could also go on and find the box points and graph from there, and all the rest of this hyperbola is there. And it all comes in because of this relationship right over here, that because of the rise and run, or the slope of the asymptote, it gives us the relationship of b and a, 2 over 1. And once you have that relationship, now you can substitute one for the other in our Pythagorean theorem relationship over here. And given the one c value already, we can solve for one or both of the other values. So I hope this was helpful in solving out a problem where maybe some information seems to be missing. Even though it seemed to be missing, it wasn't. We were able to solve it out without any more information. Hope you've enjoyed that video. We have one or two left to go in this chapter, and that will conclude our conics sections.